Hey guys, today's lesson, variables and equations. We've done a lesson very similar to this earlier called variables and expressions. And the way we started off that lesson was to first say what the difference was between an expression and what an equation is. And we're going to do the same today. If we remember, an expression is something that does not have an equal sign. An equation does. So a couple examples of expressions here. Something like if I did x plus 7. That's an expression, and we wouldn't be able to do anything with that unless they told us what x was. If they told us x was 3, then we could do 3 plus 7 equals 10. But that's an expression that does not have an equal sign. Something more complicated, things that we've been working with recently. 3x minus 19 would be an expression. And then finally, even if we had something that was a distributive property, like 4 times the quantity of r minus 16, now, of course, we could even simplify that a little further if we wanted to. We could take that and do 4 times r is 4r, and then 4 times the negative 16 gives us a negative 64. So we'd get 4r minus 64. That would be the same thing. Really makes no difference. It's still an expression because it does not have the equal sign. As soon as we have something like this where we throw on the equal sign, x plus 7 equals 12, okay, that's what makes it an equation because these two things are equal. And then 3x equals 15, also an equation. The big difference between these two things is when you're doing an expression, we can't solve those things unless whoever makes the problem tells us what the variable is. Like in this case, they would have to tell us what x is so that I can add it to 7 to be able to solve it. With an equation, since they go ahead and tell us what the answer is, they're telling us that this x plus 7 equals 12, what we're going to be able to do today is just using mental math. We can figure out what x is, because we can say what number plus 7 equals 12, and we'd be able to figure out on our own that x has to be 7, because 5 plus 7 equals 12. But I wanted to start with expressions and equations. What we did before earlier this year is what expressions were, how to write expressions and how to solve those. Now we're going to move on to equations today. So that's what today's lesson is, working with equations. I won't talk too much about this. Writing variable equations, and what I'm going to say here is, because I copied this from an old lesson, we're not doing expressions. Today we're going to be writing variable equations. Okay? But it's the same chart that we wrote down here before. Words that mean addition, subtraction, multiplication, and division. I'm not going to go over all of them, but a couple of them that I'm going to point out that we absolutely should know. Sum. The sum means the answer to an addition problem. So anytime you hear the word sum, means that we're adding. Difference is answer to a subtraction problem. Product is the answer to a multiplication problem. Finally, quotient is the answer to our division problem. And then the last thing I'm going to point out here is if you remember these more than, fewer than, less than. Those ones right there were a little tricky because remember if I said 3 more than your age, all right, a lot of people would, if I write that down, 3 more than your age, a lot of people would want to write just the way it's read. 3 more than means plus and then your age. But we remember on these types of problems, as soon as that more than, less than, fewer than comes in, actually we have to flip those two things around and we would say your age plus 3. We need to know your age first, and then 3 more than that we'd be able to figure out. Okay, example 1. Write an equation for each verbal sentence. So same thing we did before with expressions, except really the only thing new today is there's going to be the equal sign in an answer. And you could always tell what that is because it's going to say something like this, where it says is 9 or is equal to 9. Well, that's very easy. If it says is 9, that's going to be our equal 9. The sum of x and 6 is 9. The is means equal. We can even write that over here. Is, let's go back, means equal. Okay? Is means equal. So when you see the is, that's an equal sign equals 9. The sum of x and 6. Okay? The sum means that we're adding. What are we adding? X and 6. We're adding x plus 6. That's going to equal 9. And we have our answer. It's as simple as that. Okay, part B. The product of negative 4 and p is 32. Again here, I see this is 32. That's going to be the equal 32. The product. Product is the key word, means we're multiplying. What are we multiplying? Negative 4 and p. Negative 4 times p. I'm not going to put the times symbol in there. I'm just going to crunch them together. So I have a coefficient and a variable, and then that's my final answer. Negative 4p equals 32. So that's the first part of the lesson today, being able to change a verbal sentence into an actual mathematical equation. Okay, next thing. If they're able to give us an equation like this, something like x minus 5 equals 2, well, we're going to go ahead and write that down. That's the equation that we're starting with. X minus 5 equals 2. And then what they're going to ask us to do here, it says tell whether 9 or 7 is a solution. So we're really trying to check here if one of these two is what x is going to be. So really all you're doing is plugging it in here. Let's start with the 9. And you say, well, what's 9 minus 5? Is that 2? Well, of course it's not, all right? No, it's not, because 9 minus 5 should be 4. Okay, so we know that that one doesn't work. Then let's take the 7 and plug it in. So 7 minus 5 equals 2. Well, sure, 7 minus 5 is 2, so we would say that 7 is a solution. Okay, we're simply saying which one works. So if they give you an equation and they give you choices like this, that's even easier. They give you the choice, 9 or 7. Well, of course you can figure that out. 7's the one that works. That's the solution. Okay, last thing here, solve using mental math. I love it when they say use mental math, because that gives us the right to really not show our work here. This is something that should be pretty easy, pretty straightforward, able to do in our head. And the one thing I'm going to point out here, and I'm going to let you do a couple of these, is this. When I see a variable here, in my head what I should be thinking, instead of saying the word variable, I should be saying what number. So to me, for problem A, this equation reads what number plus 3 equals 11. Okay, well, I can figure that out really easily. X has to equal 8, because 8 plus 3 is what equals 11. So by using mental math, I'm able to solve that. Okay? And I'm going to go back here. I'm going to show you a little trick, because it might come in handy if you get a little stumped here. What might come in handy is this. Working backwards, okay? Rather than saying what number plus 3 equals 11, now I know we can do that one pretty easy, but just to point the rule out here, is we start with our answer, 11, and let's work backwards, okay? And what we're going to do here is, instead of saying this is plus 3, what we want to do then is the opposite. So instead of saying what number plus 3 equals 11, let's work backwards and do 11 minus 3, okay? And 11 minus 3 is what gives me 8. So you can do that on all of these, okay? When I see a minus sign here, instead of doing the subtraction, I can add. Instead of doing a multiplication here, I can try dividing. Instead of seeing the division here, I can do multiplication. Okay, and that is a trick if you don't get it right away. I'm going to let you guys try B, C, and D. So go ahead and pause the video and then come back and see the right answers. Okay, should be back here. So part B, 16 minus what number? Again, I like to say the word what number. 16 minus what number equals 9? And you should be able to figure out that m is going to equal 7, because if I put 7 in there, 16 minus 7 equals 9. Now, if you work the backwards technique, 16 minus what number equals 9, well, instead of subtracting what number, what you could do is do 9 plus what number equals 16, and 9 plus 7 equals 16. So that's the working backwards technique. Okay. See here, 5 times what number equals 20? Well, 5 times 4. So t has to equal 4. Again, working backwards, instead of doing 5 times what number, what you could do is go the opposite way and do, instead of multiplication, you can do 20 divided by 5, which is still going to equal 4. So a little trick. Probably the work backwards technique, to me, works best on these division problems. Okay? Remember, fraction bar means division. So we're saying what number divided by 6 equals negative 3? Well, that one might be a little tougher to come up with in your head. So if I know that means divide, okay, working backwards, we're going to just do the opposite of that. Instead of dividing, let's start with the negative 3 here, and let's work backwards and multiply. What's negative 3 times 6? Well, negative 3 times 6 is negative 18. And you could plug that in and see if it works. Negative 18 divided by 6. 18 divided by 6 is 3. Negative divided by a positive is a negative. So yeah, it checks out. That's our lesson today, guys. Ask questions if you have them.